Hi guys, I'm back to talk more about atmospheric pollution. Sorry, I got a little bit awkwardly cut off by a little baby drama at the end of the last one, so I didn't leave at the most logical place. So hopefully you're watching this one kind of right after you watch the first one, we can kind of pick up where we left off. So let me share my screen. Share. Slideshow. Okay, so we have been talking about these six main, what are sometimes called criteria pollutants, or these kind of six pollutants that were set in the 70s as were considered by the Clean Air Act to be kind of the most prevalent and important pollutants. So just to review, those were particulates, so like PM 2.5 and PM 10, NOx, nitrogen and oxygen compounds, sulfur dioxide, lead, ozone, and carbon monoxide. So we kind of left off talking about ozone. And ozone, we said, is actually something that's commonly a secondary pollutant. So meaning something that is not actually coming directly out of like your exhaust pipe or coming out of a coal-fired power plant, for example. Those are the two kind of main sources of a lot of our atmospheric pollutants. But instead, it's something that is created as certain kinds of pollutants react with other compounds that are naturally occurring in the atmosphere. And usually that happens as a result of photochemical oxidation reaction. So the energy from the sun kind of bombards these different compounds in the atmosphere and then forms kind of a secondary or new compound. So ozone down near the ground is one of those. And remember, ozone down near the ground is something that's undesirable. It's an irritant to things like eyes, also can be problematic for lungs. And that's really different than ozone that we see up in the stratosphere, like several miles up in the atmosphere, 10 miles up in the atmosphere. And the ozone up there is good. It's not in contact with living organisms and like other compounds on the Earth's surface. And up there, it's doing an important job protecting us from ultraviolet radiation. Okay, so we commented that, and then we were talking about one of the things that ozone does that's undesirable is it leads to the formation of smog. And so I think a lot of us are familiar with smog. We kind of know it when we see it, but it's not maybe something that we could exactly define. So smog is a combination between these fine particulate matters, the PM 2.5 and the PM 10 that we mentioned, and also ground level ozone. So ground level ozone, remember we said, again, is obviously or often a secondary pollutant formed when things like NOx, nitrogen and oxygen compounds like NO2 or NO3, combined with VOC. So those are volatile organic compounds. These are different kinds of organic compounds that are coming out of like when your gasoline is burned and it's not burned completely. We have these different kinds of organic compounds that get vaporized and they combine with the NOx and then with the energy from the sun to form the O3 compounds or the ozone compounds. So we struggle a lot with smog in certain parts of California, specifically in the Central Valley and specifically in the Southern Central Valley. So places like Bakersfield, where my husband is from, are kind of notorious for having really terrible smog problems. So again, that's because they have a lot of particulate matter in the air and also a lot of this ground level ozone in the air. So on the left here, I have a little map from the American Lung Association showing Bakersfield topping the list as the most polluted cities in the nation based on pollution produced from power plants, cars, refineries, and other sources. Bakersfield, Los Angeles, Visalia, Porterville, Fresno, and Sacramento are all among the top 6 most ozone polluted cities. So that's not that desirable. And then there's some other kind of manufacturing locations in the eastern part of the country that struggle with this as well. And then we also know that places like Bakersfield, one of the problems that they experience is that they have a lot of agriculture, and a lot of this agriculture kind of leads to a lot of one particulate matter getting up in the air as like fields are plowed and wind blows soil around and agricultural machinery blows soil around and like fields like rice fields are burned. And then also as a lot of fertilizer is applied, that can also lead to a lot of pollutants getting in the air, and things like NOx, nitrogen compounds, and we know a lot of fertilizers are nitrogen-based fertilizers, can come from this. So on the right, I'm showing this UC Davis study showing that fertilizer application contributes up to 40% of California's smog problem. So it's not really a surprise the places in the Central Valley that experience a lot of this agriculture have a lot of these pollution problems. Okay, so then while we're on this topic, I just have acknowledged a couple times that ozone, while it's a problem when it's down at the ground, is a benefit to us when it exists in its natural forms up in the stratosphere. And several decades ago, we started to have a problem where we were experiencing a hole in our ozone layer, which I think a lot of people have heard of. And this was came to our international awareness in the 1980s. And we realized that certain kinds of aerosols, and especially chlorine-based aerosols, so these tiny kind of suspended particles and liquid droplets that had different kinds of chlorine compounds that were coming from like styrofoams and refrigerants, these were getting into the atmosphere, and they were combining with ozone to break the ozone apart. And when that happened, then more ultraviolet radiation was able to get through the stratosphere all the way down to the surface. And this is not good. Ultraviolet radiation is not good for us, but it's also not good for other kinds of organisms. And we know this does things like create skin cancer in humans. And so this is kind of widely touted as a success story in environmental policy, where really quickly after we realized what was going on, the international community got together and created what was called the Montreal Protocol in the mid to late 80s. And they kind of formed an international agreement or treaty to phase out the use of these different kinds of CFCs, or chlorofluorocarbons, is what CFCs stand for. So chlorofluorocarbons are also greenhouse gases, but I just want to make sure everybody understands that this is not the reason that we are experiencing global warming. I hear a lot of students saying, oh, it's been warming because we have this hole in the ozone. That's not true. The hole in the ozone is not letting in more infrared or heat energy. It's just only letting in more ultraviolet radiation, which is, again, undesirable, but not really the same as the climate change issue. So anyway, these are these little aerosol pictures, little aerosols down at the bottom. That's what an aerosol is. So again, this is widely touted as an environmental policy success story. You can see the GWP gross weighted production of these different kinds of fluorocarbons in the 80s, in the mid 80s, and then right around 1987 when this protocol was passed, there was this huge drop off in the use of these different kinds of fluorocarbons. And that was a great success. And we can see that the ozone minimum, so the hole is mostly located over Antarctica, where some of the air is coldest, which made the breakdown of the ozone most vulnerable. You can see a picture up on the right, and then you can see a graph at the bottom showing the size of the hole, and the size of the hole has been getting smaller over the last few decades, kind of correlated with the reduction in these fluorocarbon production that we see in the upper graph. So now we weren't creating nearly as many fluorocarbons as we are creating carbon gases through all our industrial production. So it's not quite as easy to decarbonize our economy as to defluorocarbonize our economy. But this does show us that it is possible to have international agreements and to really make changes when we see that we are suffering as a result of the kinds of decisions that we're making. Okay, so before we move on to a few last things, I just kind of want to mention that there's a lot of research that's come out in the last couple months showing huge improvements in air quality associated with big drawdowns in transportation and industrial processing and manufacturing associated with a lot of stay-at-home orders in the United States, but also in many places around the world. In China, They had huge shutdowns of lots of energy and manufacturing. And this was also true in many parts of Europe, like in Italy and Spain, and in the Middle East as well. And it's kind of interesting and kind of a promising story to learn that when we do change the way that we're manufacturing materials, we can really quickly see an improvement in the quality of our atmosphere. So this particular graph is showing 2019 NO2, so that's a kind of NOx pollutant issue, and then 2020. And so we can see that in places like Los Angeles, we have a 33% reduction in NOx in the atmosphere this March and April compared to last year. Seattle, it's down almost 20%. New York down almost or over 20%, Denver 15%. And so these are big improvements to air quality, and there's lots of different kinds of stories on the news, like people in Los Angeles saying, well, I can see the mountains better than I've ever been in my whole life. And lab folks have an opportunity to read an article about this issue more widely, that more in kind of international scope of this story for lab this week. But anyway, I just want to mention it's kind of interesting to see that when we do make changes, we can see quick rebounds and that quality of our atmosphere. So of course, none of us want to have, well, maybe most of us are not looking to have an economy that's moving as slowly as it is and having an economy that manufactures as little as it is right now. But if we can think of creative solutions about how to still have different kinds of economic productivity without creating so many atmospheric pollutants, we could really be looking at a much cleaner future. And a lot of countries, especially EU countries, are really taking this as a moment to reevaluate the way that they're creating pollutants and are thinking about, as their economy is coming back online, how they're going to try to make changes so that they can live in a cleaner environment in the future for better health outcomes. Okay, so kind of a few more things to finish up about atmospheric pollution. All these topics are huge and we're trying to shove them into like a week each. But another important contaminant is mercury. And this is not one of the criteria or conventional pollutants that was originally listed as one of the main 6 in the Clean Air Act, but it is something that's regulated as a non-conventional pollutant in the Clean Air Act. And it is an important health impacting pollutant. The source of a lot of mercury is burning coal. So coal sometimes has mercury as an impurity in the coal, and when we burn it, the mercury gets into the atmosphere. This can also happen when we're doing smelting with other kinds of metals or burning waste that has maybe some very small amounts of mercury in it. It can get into the air in that way. And it is really a problem because it's a neurotoxin like lead. It creates brain and nervous tissue malfunction. So this is obviously a big health concern. Hg is the chemical symbol for mercury. So we do have a lot of mercury around in our environment in the Sierra Nevada. However, our biggest exposure comes not through breathing in the air, but through eating fish. So a lot of mercury was put into our environment in the gold mining era because the mercury was used to bond to the gold and pull it out of the sediment. And so a lot of this mercury is now in our waterways. And when the mercury stays in a form where it's disconnected from the oxygen, it's actually not as toxic to us. However, there's different kinds of aquatic bacteria that can transform these inorganic forms of mercury, this HGS or mercury sulfide, into what's called methyl mercury, which is a bioavailable form of mercury. So then that mercury can get into the aquatic food chain. And then if we are part of the aquatic food chain by eating fish, we can ingest this as well. And this is definitely a problem in places like California, where we've had a lot of historic mercury pollution, but this is also true in eating ocean fish, and especially ocean fish that are kind of higher up on the food chain that have eaten a lot of other fish and accumulated a lot of this mercury through their lifetime. So that's why, pregnant people are advised to like not eat tuna, because tuna are older, longer lived fish that have ingested greater amounts of fish in their lifetime and therefore accumulated more mercury. So here's kind of an advising sign. I grew up in the Bay Area, and there's these kinds of signs all around where people are fishing. And this is kind of showing different kinds of fish, and depending on usually how old they are, how long-lived they are, how dangerous they might be in terms of your mercury exposure on eating them. And so certain kinds of smaller and shorter-lived fish are probably safe to eat in a limited setting. And then other sort of slightly bigger fish, halibut, maybe safe one time per week. And then things like striped bass are recommended to not eat, especially if you are pregnant, breastfeeding, or a child, because the mercury that's in these fish could create some kind of neurotoxin problems for you and for your long-term health. Okay, so one other kind of non-conventional pollutant, so another pollutant that's not considered part of those original 6, is carbon. So we're increasingly aware, and we've talked extensively about this already, that carbon, compounds like carbon dioxide and methane are greenhouse gases, or GHGs. And so as of 2011, the EPA is now regulating these greenhouse gases as atmospheric pollutants, because we have, of course, a recognition that these greenhouse gases, while they're not toxic to us as we directly inhale them, they do endanger the health and welfare of both current and future generations because of their impact on our environment in the short and long term. So they can impact our health, things like increasing the temperature, impacting the air quality, extreme climate events, could lead to injury and disease, climate sensitive diseases, et cetera, et cetera. So like there's definitely direct health impacts associated with global warming. And then of course, our welfare as a society is very related to the stability of our climate and the ability of our infrastructure to withstand changes to the climate. So we know that agriculture is dependent on climate, forestry is dependent on climate, our water resources are dependent on climate, our coastlines are changing with climate, our energy demand is changing with climate, and our ecosystem services and wildlife are as well. So we've already talked a lot about climate change and biodiversity, and we'll talk more about water resources next, but I don't think it's a surprise to any of you at this point that even though, again, breathing in CO2 at levels in the atmosphere is not necessarily toxic to you. At extreme levels could be toxic to you. But at levels that we see today are not directly toxic, but they do have certainly health and welfare impacts, which is why they're now regulated. Okay, so I just want to show you this quick video here. Is this going to let me go? Showing you these greenhouse gases in the atmosphere. So let's see if this will work.
Climate scientist at NASA's Goddard Space Flight Center. What you're looking at is a supercomputer model of carbon dioxide levels in the Earth's atmosphere. The visualization compresses 1 year of data into a few minutes. Carbon dioxide is the most important greenhouse gas affected by human activity. About half of the carbon dioxide emitted from fossil fuel combustion remains in the atmosphere, while the other half is absorbed by natural land and ocean reservoirs. In the Northern Hemisphere, we see the highest concentrations are focused around major emission sources over North America, Europe, and Asia. Notice how the gas doesn't stay in one place. The dispersion of carbon dioxide is controlled by the large-scale weather patterns within the global circulation. During spring and summer in the Northern Hemisphere, plants absorb a substantial amount of carbon dioxide through photosynthesis, thus removing some of the gas from the atmosphere. We see this change in the model as the red and purple colors start to fade. Meanwhile, in the Southern Hemisphere, we see the release of another pollutant, carbon monoxide. This is a gas that's both harmful to the environment and to humans. During the summer months, plumes of carbon monoxide stream from fires in Africa, South America, and Australia, contributing to high concentrations in the atmosphere. Notice how these emissions are also transported by winds to other parts of the world. As summer transitions to fall and plant photosynthesis decreases, carbon dioxide begins to accumulate in the atmosphere. Although this change is expected, we're seeing higher concentrations of carbon dioxide accumulate in the atmosphere each year. This is contributing to the long-term trend of rising global temperatures. The Orbiting Carbon Observatory 2, or OCO2, will be the first NASA satellite mission to provide a global view of carbon dioxide. OCO2 observations and atmospheric models like GEOS-5 will work closely together to better understand both human emissions and natural fluxes of carbon dioxide. This will help guide climate models toward more reliable predictions of future conditions across the globe.
Okay. So hopefully you get a sense of how we have certainly these carbon sources coming from places like China, like Europe, like the United States, and also kind of the international global scale of all these atmospheric pollutants. Just like we saw in that original video at the beginning of the first lecture, you can kind of see how atmospheric pollutants don't stay in one place, but what's going on one continent is going to be affecting many others as well. Oh, can I move on to the next slide? Okay, so we do have some new carbon regulations as part of the Clean Air Act, as monitored by the EPA, Environmental Protection Agency. So these new new policies have greenhouse gas emission standards and fuel economy standards for cars and trucks. They have pre-construction permits that limit greenhouse gas emissions from large new stationary sources when built, or are going to undergo major modifications. So these are kind of the two main ways that we're trying to regulate how greenhouse gases are getting into the atmosphere. And so there's federal regulations. Many states also have their own regulations. So like California's regulations are more strict than the federal standards. And that's something that's actually, they're getting sued by the federal government over, which is a whole complicated issue that we're not going to get into right now. Okay, so what can we do to clean up our air? Well, we know that the main sources of atmospheric pollutants are transportation and energy production, particularly coal-fired power sourced energy. So we can try to be creative about using our transportation more minimally, carpooling, investing in kinds of greener transportation, voting to have our government make investments in cleaner transportation options, and thinking about how we can change our dependence on these kind of dirty energy sources. And again, a lot of times this isn't something that we can necessarily do by ourselves in our homes. Maybe we have the opportunity to do things like buy solar panels, and if you do, that's really great. But a lot of times this is more of requires a kind of a government scale or societal scale change. And so we need to kind of make our voices heard that these are priorities that we think are important, that we think we should be investing in. And so there's kind of an important role that you can play there. And generally, we just need to reduce our fossil fuel dependence, because a lot of our energy, whether it's going to electricity production or transportation production, is really creating these problems for us. So again, being creative about technology solutions and policy solutions to try to kind of wean us off our fossil fuel dependence are really going to be tickets that are going to be important for the health of our future. So that's a wrap. That's all I have to say. Okay, take care.